All right, we're going to look at the last section in topic 7 today, 7.5, and it's called proportions in triangles. And it says when we take a triangle and we draw a segment across the triangle, and that segment happens to be parallel to the bottom side of the triangle. So if those two lines in the triangle are parallel to each other, what this says is that the sides will divide the other two sides proportionately. So that line that's drawn through here is going to divide the sides of the triangle in a way that is proportional. So if I were to set up the proportion, I could say 12 over 6, the side length of the upper part of this compared to the lower part of this is going to be in the same proportion as the other side of the triangle. The upper portion is in the numerator and the lower portion is in the denominator. Okay, notice that the two lower portions of the segment are both in the same position in your proportion. That's important that you do that. The two segments that are in the upper part of the triangle, they're in the upper portion of your proportional. Okay, and if I look at this, if I look at the cross products, 12 times 5 is 60. And I compare that to this product, 6 times 10 is 60. So you can see that those are proportional to each other. And that's what theorem 7.5, they call it the side splitter theorem. Basically, that's what it says. If we draw a parallel line through this triangle, then the two sides of those triangles are going to be split proportionately. Okay, we're going to use that theorem to find the lengths of missing sides. So this particular question, it says we can use this theorem to figure out the missing length. Okay, so here's my parallel lines. Notice the two sides of the triangle have been split proportionately. So they wrote the proportion x, or 8 over x. So they put the smaller or the lower portion in the numerator and the upper portion in the denominator. So if that's the case, then I just need to make sure I follow that same line of reasoning over here. I'm going to put the lower portion, the 7, in the numerator, just like it was over here, and I put the upper segment in the top in my denominator. Okay, so they're going to occupy, these two pieces that are both above are going to occupy the same place in the proportion. Okay, we know how to solve that by now. Okay, once we set up our proportion, we're going to look at our cross products. So we're going to take 8 times 12. 8 times 12 is 96. And that is equal to this product here, which is 7x. Okay, we're going to solve that. We're going to divide both sides of the equation by 7. Okay, and that would be x equals, now that doesn't go in evenly, so we're going to get a decimal out of that. I'm going to use my phone here as my calculator. Real quick, 96 divided by 7 equals, I get 13.7. Since I'm rounding that, instead of a traditional equal sign, you see that wavy sign because we've rounded our answer. And pay attention to the directions if it's asking you. In this case, I rounded to the nearest tenth. Okay, you might have to label your own triangle. It says given the segment B to D. B to D is this portion up here, that's 12. C to E down here is 12. It says B to E is 16. They want you to find A to D. So you might have to label your own picture, but you can do that. And then just like the problem above, we're going to set up a proportion. We're going to say 12 over x. I'm just going to keep it in the way 12 is on the top, x is on the bottom. So when I go to the other side, I have to make sure that 16 is on the top, 12 is on the bottom. Okay, we solved that by taking the cross products. Okay, so I'm going to take 12 times 12. 12 times 12 is 144. That's going to equal this product, 16 times x. Okay, to solve that, I would have to divide by 16. So if I use my calculator again and I take 144 and I divide it by 16, the answer equals 9. And I don't have to round that. It came out exactly 9, so I use my equal sign for that. That distance from A to D is going to be 9 units. Okay, it says the converse is also true. It says if the segments formed are proportional, the lines must be parallel to the side of the triangle. This property extends to multiple parallel lines. So within a triangle, I can draw as many lines as I want to. If all of these lines are parallel to each other, then that means that all of these segments are going to be in the same proportion to each other. Okay, so we could say that 9 over A, okay, 9 over A is the same as 14 over 16, same proportion. Now, notice that if I go this way, I could solve that as well. I could say 9 over 14 is equal to A over 16. I could set my proportion up either going this way, up and down, or I can go across. If I go across, these are both in the same part of the triangle. So I have this here, the side that's on the left, I put in the numerator, the A is in the denominator. So when I go to my next proportion, the side that's on the left should be in the numerator, the side that's on the right should be in the denominator. Okay, so you can do it that way. You can also go up and down with that and put that, the upper piece is 9 over 14, so that's in the numerator, put A over 16, the upper piece is in the numerator. So there's multiple ways that you can set this up, and the reason for that is if you looked at those two proportions that you just set up, if you look at the cross products, when you do the cross products here, you get 9 times 16 is equal to 14 over A. Well, it ends up being the same thing here. If you do cross products, you're still going to take 9 times 16, and you're still going to set it equal to 14 times A. So there are a couple ways that you can set these problems up and still get the same result. When you solve that, you're going to get approximately 10.29. Most of the time, I believe the directions are going to ask you for the nearest tenth. So in that case, I would say 10.3. Now what's really important is when you do these other ones, I can't use these two proportions because you notice I've got two different variables. You always want to go back to the segment that you know both parts to. Since I know both sides of that triangle, that is the proportion that I continue to go back and use. 14 over 16. If I want to find B now, I can set it in proportion to this segment. Since 14 is on top, I'm going to put B on top. B is over 18. And again, you're going to take your cross products and you're going to solve that. And when you do that, you get 15.75. If I wanted to round that to the nearest tenth, that would round to 15.8. Okay, and then again, I found B. I'm going to come back to that same proportion and use where I knew both values for it. So 14 over 16 is equal to, this time we're going to find C. So 14 over 16 is equal to 8 over C. If you wanted to set that up vertically and say 14 over 8 is equal to 16 over C, you could do it, you could set that up as well. Because again, look, when I take the cross products, I'm taking 14 times C. Now I do the same thing with that. And it's equal to 8 times 16. It's going to be equal to that. So you're still getting the same cross products, no matter how you set that up. But again, you can only have one variable in your proportion. So make sure you keep coming back to the proportion where you know both pieces too. When I solve this one, I get C is approximately 9.14. If I want to round that to the nearest tenth, that would be 9.1. Okay, read the directions. If it asks you to round to the tenth, this is how you're rounding. If it asks you to round to the hundredth, then we would leave it as they have in the packet. Okay, and then the last thing I want to look at is it says an angle bisector in a triangle divides the opposite sides into segments that are proportional to the adjacent sides. Okay, this is on page 9 of your packet. So when I have an angle bisector, we've already talked about what an angle bisector is. Okay, when I've got a line coming out of that vertex and it's going to cut the angle in half, what they're saying is that how it divides the opposite side is in the same proportion as these sides of the triangle. So I can set this up and I can say 14 over x. So this side of the triangle is in the numerator. That means I have to put this piece, this 24 is in that same triangle. So 24 would have to go in the numerator and 30 in the denominator. Okay, we could set that up. And then we can solve that with our cross product. So I have to take 14 times 30. Okay, if I take 14 times 30, I get 420 equals 24x. Let me use my calculator again. Divided by 24, I get 17.5. And I didn't have to round that, it comes out exact. So x equals 17.5. Okay, that's your triangle angle bisector theorem. When you have an angle that's being bisected like that, it divides this side in the same proportion as these pieces of the triangle. Okay, and we've got one on the very back page to try. Okay, so here's my angle bisector. It's not marked very well, but you've got this coming out of the triangle. These sides would be, that's bisecting that angle. Therefore, this piece is divided proportionately as these two pieces. So there's different ways you could set up your proportion. Okay, the way that we have it in the example here, we took this side 8 and set it in a ratio to its side G. And we said that proportion, 8 to G, is going to be the same as this triangle. Since 8 is in the numerator, 11 has to be in the numerator. Okay, over 15. Okay, and we're going to solve that. We're going to take 8 times 15. 8 times 15 is 120, and that's equal to 11 times G. The way that I solve it by dividing by 11. Okay, and G is going to be equal to, we need to take 120 and divide it by 11. And I get a value of 10.9. That is rounded, so we got that wavy equal sign, 10.9. All right, you got a worksheet that you can start working on.